The next video in the Parkour series is a double jump system with landing. The player can jump again if falling, and there is a particle and change of animation for when the second jump is active. When the player lands, if they were falling fast enough and not moving, they will play this land animation. If you landed but are moving, this different animation plays, which smoothly blends a landing animation with moving. The video also shows how to integrate it with the rest of the Parkour series, so it adds onto the double jump system made from wall running and sliding. The player cannot immediately double jump, which would look unnatural, so the player can only double jump closer to the peak of the jump. First we will get animations. I will be using Mixamo for them. The first animation is called Fall A Loop. Make sure to download it without skin. Next, get Fall A Land to Standing Idle 01. The final animation is Fall A Land to Run Forward. Then use the Mixamo converter to convert them to use the Unreal Engine standard rig. I will put a link to the software in the description. Now open Unreal Engine. I will make a new folder for the mechanic. Import the animations. Open both landing ones and set force root lock to true. This puts the animation in place as if it were root motion, but there won't actually be any movement, so if played in game the player won't actually be moving, but the animation will be in place. Create animation montages of both of them. Make a new notify at the start called lock jump. Add this notify just as the player is starting to get back up after they compress. Do the same for the other animation. Now we will get the particle effect. You can use your own for this, but I will use one from this free marketplace asset called FX Variety Pack by Kaki. I will use this shockwave particle and make a copy of it for a modified one. This one uses the legacy particle system. If you are using the same one as me, delete all the components except air and shockwave. Change the initial size of the air component to 1:760 since it was too thick before. Now open the character blueprint. First go to the begin play. I will collapse this code from the wall run video. Get the air control from the character movement and promote it to a variable called default air control. Do the same with the jump Z velocity. Now click on the root component in the left. Search for jump count and change the jump max count to 2. You can make this value whatever you want, but this video is made particularly for double jump, so only 2. Go to the jump input. Remove jump from started. Add a branch that checks a Boolean variable called lock jump. Make sure the default value of it is false. Next, get jump current count and switch on int. Uncheck as default pin and add 2 pins. This enables us to run different code based on if it is the first or second jump. If 0, add the jump node. If 1, add a branch that checks if the character movement's z velocity is less than 300. This is to ensure that double jump cannot be spammed immediately after the first jump and the player must not be moving up too fast since it may be unrealistic. You can adjust this value if you like. If this is true, then connect to the jump node. Then get the character movement and set jump z velocity. Add a select float for it. Get the jump current count and check if it is equal to 1 for the select condition. Promote A to a variable called double jump velocity, and B should be the default jump z velocity. I will set the double jump velocity to 900, but you can use any value you like. Now do the same for air control with the same condition and corresponding variables for it. I will set the double jump air control to 0.7. Next, add a branch that checks the same condition. If true, spawn emitter at location. If you are using a Niagara particle, it will be spawn system at location. Make a rotator for the rotation. Due to the nature of this particle, I will add a variable which decides the rotation. Add a select float for pitch with the condition being a new variable called double jump particle rotation switch. A should be -90 and B should be 90. For scale, make a vector with all 3 axes being a variable called double jump particle size. For this particle, a default size of 0.8 looked good. For the location, get the mesh's world location. Add a vector to it. Get the actor up vector and multiply it by a select float. The condition is the same rotation switch 1. This is the value to add. Set the select floats A value to 100 and B to 45. This is since when rotated different ways, the anchor point made it so that it wasn't directly around the center, so this fixes that. This code is only necessary if you use the same particle as me. Set the particle. Make sure this branch uses the false path and not true. I will disconnect the onJump event we used for previous videos in the series to test. Double jump is working. When the rotation switch variable is turned on, the part Now make a custom event called jump landed and call it on event on landed. In the event, first set the jump Z velocity and air control back to their default values. Then add a branch that checks the character movement's last update movement velocity Z value. Check if the absolute value of it is greater than 1100. Absolute value will return the positive value, ignoring the sign. We are doing this since when landing it will be negative, but it is easier to set and compare positive values. If true, get the mesh and play montage. Add a select node for the montage. For the condition, get the actor forward vector and get the dot product. Then get the input direction function and forward vector of it for the dot product's second value. This is a function which I made in a previous video, which I will link in the description and show briefly on screen if you want to just copy it. Check if this is greater than 0.8 for the selects condition. This checks that the direction we try to move in after landing is close enough to the actor's forward-facing direction. If false, set it to land to stand, and if true, then land to run. Next, set a timer by event. Set the time to 0.01 and looping to true. Promote the return value to a variable called jump land timer. Make a custom event for the event called check stop land animation. This event will stop the animation based on conditions. Add a branch. Get the meshes anim instance and get current active montage. Check if this is equal to the land to run 1. This is the branch's condition. If true, add another branch that checks if the last movement input vector is nearly 0. If true, get the meshes anim instance and montage stop with a blend out time of 0.25. Leaving the montage empty will blend out whatever montage is currently playing. If the first branch was false, add another branch that checks the same vector is nearly 0 condition. This time, if false, connect it to the montage stop. This code will cancel the land animation if it is the landing to stand and the player tries to move, or if it was the land to run animation and the player is not moving. Next, set lock jump to false. Then add a branch that checks if jump land timer is a valid timer handle. If true, clear and invalidate the timer by handle. Copy this last part of the code. Paste it in blend out of the play montage. Both animations are working correctly. Now go to your character's animation blueprint. Add the lock jump notify. In it, set the lock jump variable from a reference to your character blueprint. Set it to not of the current value of it. This means that when called, if false it will be set to true and vice versa. Now go to the anim graph. My anim graph is different if you didn't follow along for the other Parkour series, but the changes made for this video will be in main states, which is there by default in the template, so you can add it easily. Open the fall loop state. Add a blend poses by bool with the default animation in false. Add the fall loop animation we got from Mixamo. This is the true pose. Make sure to set loop animation to true in the right. For the active value, get the jump current count from the character variable, which is a default one from the template. Check if this is equal to 2. For the last part, set lock jump to false in this branch in the character blueprint. Set it to false before the branch in montage blend out as well. The system is working correctly. That is all for the mechanics, but I will now show how to integrate it with the rest of the Parkour series, so if you followed along for them you can watch this part, otherwise thanks for watching. First, bring over the default jump code and the onJump event. Remove the current code from started and replace it with the 3 nodes from before. Make some space in the onJump event. Move the code we added for the double jump there. In onJump, connect it to the branch that checks if sliding. If false, connect it to the double jump code. Next, add a custom event called double jump particle, connecting it to the spawn emitter. This is so we can call it for the launch character in wall running and sliding, which acts as double jump. Now go to the wall jump input macro. After the launch character for double jump, call the double jump particle event and set lock jump to true. Now we will replace all instances of manually setting the air control to using the default variable we made. Search for set air control and find results. Find anywhere it is being set to the default value manually, which in my case is 0.35. This is in ledge climbing, so add the default air control variable for it instead. Next, it is in wall run on landed. This one can be deleted since we are setting it back to its default value on default on landed anyway. Now go to the ledge climbing graph. In the ledge climb input, delete all onJump calls. Finally, we will make it so the double jump animation plays if we double jump from wall running or sliding as well. Make a new Boolean variable called wall run double jumped. Set it to true after lock jump in the wall jump input macro. Set it to false after air control in the jump landed event. In the animation blueprint, go to the fall loop state. For the blend by bool condition, get the wall run double jump variable and connect it to the current condition with an OR operator. Go to the wall running graph. After both paths in the on component hit, set wall run double jump to false, as by default it should be false when wall running or sliding starts. The system now works with wall running and sliding. That is all for this video. If you enjoyed, like and subscribe for more content. Thanks for watching.